All right, let's dive right into this explainer and figure out how we can finally, and I mean finally, give our AI agents a structured, reliable brain. Because look, if you've been building agents lately, you know the struggle. Getting them to actually remember things from one conversation to the next without completely losing context or breaking down, it is tough. But today, we are fixing that once and for all.
Before we even touch the code, we have to think about this fundamental question. How do you actually give an AI a perfect organized memory? Because without it, your AI is essentially starting from absolute scratch every single time you talk to it. You know, it's kind of like having this brilliant, highly capable assistant who just gets total amnesia the second you leave the room.
So we have a really fantastic roadmap ahead of us today. We're going to cover the AI memory challenge, moving to structured memory, the JSON update bottleneck, trust call and JSON patches, the LangGraph implementation workflow, and finally, leveling up with collection schemas.
Section 1. The AI Memory Challenge. Why agents need a brain.
Let's establish why memory is the absolute foundation here. Think about it. As a human developer, you just naturally remember a past bug when you're trying to solve a new one, right? You build on those previous experiences effortlessly. But an AI agent, it doesn't do that naturally. It has to be explicitly given storage mechanisms. It has to be strictly told to remember a user's location or their interests to actually give personalized help. And for that, it requires a foundational tool, like LangGraph's base store, to retrieve that context exactly when it matters.
Section 2. Moving to structured memory, graduating from messy strings.
So the big question is, how do we actually store this context? Well, I'll tell you what we don't do. We don't just append every single conversation into one massive continuous text string. That is a total recipe for disaster. As that unstructured string grows, the AI just gets confused and forgets key details. Instead, we absolutely have to transition to structured schemas. By using Pydantic base models, we force the AI to organize its data into a super clean JSON format, perfectly categorized by keys. You know, name, location, interests, the whole shebang.
And this is crucial. By defining a really clear user profile schema like this, we give the AI a highly specific, easily searchable memory structure. So when the agent needs to remember something about, say, Lance, it doesn't have to read through a massive, messy transcript. It just looks at the specific interests field and boom, it instantly finds biking. It is incredibly efficient.
Section 3, the JSON update bottleneck, the danger of full regeneration. But here's where we hit a massive wall. What happens when we try to update that beautifully clean memory? Let's say a user just adds one single new interest. Asking a large language model to regenerate that entire complex JSON profile from scratch, that's actually incredibly dangerous. Even top-tier models like GPT-4o frequently fail or hallucinate or just drop data during full rewrites. Plus, it wastes massive amounts of tokens, it drastically slows down your processing times, and honestly, the worst part, if the LLM breaks the JSON structure just once, your entire application crashes.
Section 4. Trust call in JSON patches. The elegant savior. Fortunately, there is a magical weapon for this exact problem, developed by LangChain's Will Fu, called Trust Call. And Trust Call leverages this brilliant concept called a JSON patch. A JSON patch is basically just updating specific keys in a JSON object without having to regenerate the whole file. It only changes what needs to be changed.
Instead of sending the whole old document back to the LLM and crossing your fingers that it doesn't mess up the new JSON, Trust Call is surgical. It sends the document, but the LLM only outputs a JSON patch of the new information. The rest of the memory, perfectly intact. It takes the risk totally out of the equation, making the whole process super fast, incredibly reliable, and really cheap on tokens.
Let's put that into perspective. If Lance says his name in the initial setup and then later says he likes biking, the memory updates. Now, what if he mentions bakeries in a second chat? With a standard update, you'd rewrite the whole thing, but with Trust Call, it simply appends bakeries to the existing interest list. It doesn't touch his name, it doesn't touch his location, just surgical memory insertion.
Section 5, LangGraph implementation workflow, putting it into code.
All right, let's dive into the actual LangGraph implementation workflow to see how this comes to life. The Trust Call workflow in your agent follows these 4 exact steps, which beautifully isolates the memory update process from the rest of your agent's chatter. First, we create the extractor with our schema. Second, we invoke the model, passing the existing memory and the chat. Third, we extract the model dump. And fourth, we put it into our LangGraph base store. Step 1 is using Trust Call's Create Extractor. This function is vital because it forcefully binds your Pydantic schema directly to your model as a tool. By using the tool choice parameter, you are enforcing strict, guaranteed structured outputs every single time the model runs.
Now, once invoked, the model doesn't just hand you plain text back. It returns a complex list of tool calls. So for step 3, we use .model_dump on that first result to neatly serialize it back into a clean, standard Python dictionary. This makes it super usable for your application.
Finally, step 4. We save this pristine dictionary into LangGraph Space Store using the .put method. To do this properly, you need 3 specific things. You need a namespace, which is a tuple representing the storage location, like the user's ID. You need a key, which uniquely identifies this as, say, a user memory. And you need the value, which is simply that dictionary we just extracted.
Section 6. Next level. Collection schemas. Beyond basic user profiles.
So, we've mastered the basic hot path, but let's see how this builds into something even more powerful for your advanced projects. Basic memory is great for simple things like name and location, right? But you can evolve your agents to use what are called collection schemas. These allow the AI to neatly segment vast amounts of complex, categorized data. You could maintain completely separate lists for a user's technical platform issues, their family details, and their personal interests. And the best part? TrustCall handles these deeply nested collection schemas flawlessly, updating only the exact category needed without ever breaking the broader structure.
So armed with LangGraph stores and TrustCall patches, the technical limitations of AI memory are virtually gone. The only real question left for you is, how will you architect your own complex memory collections to give your agents a perfect memory?
Thanks so much for joining me for this explainer.